verify a trig identity. And I'm going to do a few examples of verifying trig identities, but just so you know, there's probably more kinds of identities to verify than I could possibly show in a few examples. And almost every one of them, there's probably more than one way to verify. So I'm just giving you a few examples of how they might work out. So normally we would attack the more complicated side first, and that's clearly 1 minus sine squared over 1 minus cosine. What I'm thinking in my math mind is that because I've got a 1 minus cosine in the denominator here, I have sine squared in the numerator, and I'm very comfortable with the substitution that 1 minus cosine squared equals sine squared. And that's the difference of squares, 1 minus cosine times 1 plus cosine. So I can see right away that if I do that, I'm going to be able to cancel that factor of 1 minus cosine theta in the denominator. So that's my strategy. Now, you would not be wrong to say, let's find a common denominator between this fraction, 1, and this fraction. Now, I'm sure that it would work out, but that's not the way I'm going to do it. I'm going to say 1 minus 1 minus cosine squared theta over 1 minus cosine theta. And that is 1 minus 1 plus cosine theta times 1 minus cosine theta over 1 minus cosine theta. Okay, now 1 minus cosine theta is a factor of the numerator. It is a factor of the denominator, so it cancels. So now we have 1 minus 1 plus cosine theta, but without parentheses, that will become 1 minus 1 minus cosine theta. And the 1's cancel, and that is just negative cosine theta. And that is the same as the right-hand side. So that identity is verified.